A giant special-purpose vessel on 6 legs with wind turbines almost 150 meters tall, far out in the North Sea, off the coast of Sylt. This is where one of the largest wind farms in the German North Sea is being built. 80 wind turbines are being erected here in an area of around 70 square kilometers, in record time and at dizzying heights.
Back to being a dream job again.
Thanks to precise planning and high-tech equipment, it takes just 1 day to install a wind turbine. The most modern installation vessel in the world is in operation.
It does require accuracy and precision.
Working in all weather conditions, 24 hours a day, 7 days a week. At the quay wall, the towers for the wind turbines are waiting to be loaded. The 66-meter-high giants stand in the harbor of the Danish city of Esbjerg. The nacelles are pre-assembled and lined up precisely. Everything transported and loaded here is large and weighs tons. The equipment and means of transportation are just as large. Strange-looking vehicles designed especially for this task help transport these monsters. The special crane moves slowly to the next nacelle. The flatbed is also on its way. Its driver maneuvers the remote-controlled vehicle towards the nacelle. The vehicle is extremely mobile. Each of the 12 8-wheel axles can be steered. Now the crane lifts the nacelle a good meter off the ground. Then the flatbed drives underneath it. With all their strength, the loading workers pull the heavy nacelle into position so that it can be fixed precisely and securely. The nacelles are completely finished. Later at sea, they will be placed on the towers and then connected. Gearboxes, cables, connections, everything necessary for producing electricity has already been installed and checked. A 10-minute journey brings the nacelle to the quay edge. The dock workers work around the clock. The time of day doesn't matter to them or the ship's crew. The loading of the nacelles, also known as gondolas, takes all night and part of the next day. There's room for 10 nacelles on board the Pacific Osprey. The process must be completed within 2 hours. Otherwise, the schedule is thrown off course. The nacelles are mounted on platforms, which are then fixed on board. This ensures that nothing slips during transport. Danish dock workers are responsible for the loading. Only union-approved dock workers are allowed to load and unload ships in Danish ports. They work in practiced and well-rehearsed teams. They will load the ship a total of 9 times until the wind farm is ready. On deck, the installation technicians oversee the work because it's extremely important that every part on the ship is placed correctly.
There's a specific sequence used for loading which ensures everything can be taken off the boat in the right order, and of course that the boat isn't thrown off balance while we're taking the parts off bit by bit and sailing to the next mill.
Even loading the imposing plant components is a matter of centimeters. With a length of 161 meters, the Pacific Osprey is the largest installation vessel in the world. Yet every centimeter of the deck must be used precisely for everything to fit. The towers have already been assembled from 3 parts on shore. Now, the crane hoists them on board in one piece. They weigh between 230 and 273 tons. And they have everything they need to produce green electricity in the North Sea, like dehumidification systems that protect against rust, hundreds of meters of power cables, and an elevator. With it, the installation workers and service technicians can get to the top quickly and easily. Loading is millimeter work. 136 bolts have to be inserted exactly into the tower's receptacles. Then the technicians inside the tower tighten the bolts one by one. Each one is made of special steel and weighs 7.5 kilograms, including the nuts. Later, when the tower is installed at sea, these screws fix it to its foundation. It takes the dockers a good hour to secure a tower on board. Then it's time for the rotors. The blade rack was constructed specifically for them. The ship's auxiliary crane and a mobile crane on shore work together to lift the rotors into the oversized rack. It's all about precision here, too. The coordination of the 2 crane operators in particular requires the utmost concentration on all sides. If the weather is good, and more importantly, if the wind plays along, all the components will be on board within 2 days. Loading takes place around the clock. Time is money, because the installation vessel is chartered for the construction of the wind farm. Every hour that the ship has to be rented incurs costs in the thousands of euros. When loading is finished, the ship's main crane moves into its cruising position. Cast off is now the motto. Now the bridge of the ship takes command. The Pacific Osprey belongs to a shipping company that charters out special ships worldwide for the construction and supply of offshore projects. Both the captain and crew are experienced professionals in this field. After casting off, the ship heads out of the harbor through the narrow channel towards the open sea. On the bridge, the captain and officers are highly focused on their work. The Pacific Osprey's crew numbers around 30. Officers, engineers, technicians, kitchen team. They work in 2 12-hour shifts. The crew is on board for 28 days at a time, far away from their families, without a mobile phone network. Then 28 days of home leave follow. For Captain Henning Andersen, the long shift work has clear advantages.
When I'm at home, I'm at home. It's just like a switch. When I go down the gangway, I'm at home. I don't have to think about what's going on out here. We have to do this tomorrow, and we have to order this, and how's the weather forecast? And but when I'm here, I don't have to think about, okay, I have to pick up the kids in kindergarten. I have to go shopping. I have to prepare the food, I have to clean, I have to do the laundry, and everything is taken care of. The only thing I have to do here is work.
The wind farm is located in the North Sea, about 70 kilometers west of Sylt. Its name Dantysk is derived from Dan for Denmark and Tysk for Tyskland, Danish for Germany.
We have a very good soil structure for our foundations and moderate water depths between 21 and 32 meters, even though we are very far out from the coast. We have constant winds from the southwest, which lead to very little shading effects with the park layout, so we can really operate the park very efficiently.
After about 6 hours of sailing, the installation vessel reaches the construction site in the North Sea. Already installed wind turbines can be seen from far away in the waves. The target of the Pacific Osprey are the yellow masts that rise out of the water. The next turbines will be installed onto them. The helmsman and captain hand over the helm to the computer, the so-called dynamic positioning system, for the last few meters.
At the moment, the DP system is setting up, find out about the environmental forces, the wind and the sea, and it takes some time to build up like a model, it's called. Give it 10 minutes, and that should be it. And then we start moving into the final position.
The position of the ship has to be accurate to the meter. No easy feat with the wind and the waves.
So, 220 meters.
Two mounting positions are given. The captain decides which one the computer heads for, depending on the weather. The ship needs a precisely measured distance to the so-called transition piece, so that the ship's crane can work optimally.
Yeah, that's fine. We don't need to be that accurate. It's okay to be a little bit east of the, as we are now, that's fine.
Extensive soil analyses were carried out in advance.
The owner of the park, Vattenfall in this case, gets some companies to do the different surveys. They survey for old bombs as well. There might be something from the Second World War, for example, so they get that checked.
The Pacific Osprey is the largest installation vessel in the world, and here it's in action for the first time. But the ship has to be able to do more than just float in order for it to carry out complicated construction work safely and accurately on the high seas.
To install such big turbines, we need a jack-up vessel which allow a stable work platform. A jack-up vessel means that the whole vessel are jacked out of the water up in a certain height. And as you can see, the legs here will go down to the seabed and support the whole vessel when it's jacked up.
Yeah, legs down.
Osprey, main leg, come down on legs.
The ship has legs, 6 of them, each weighing 800 tons. When the Pacific Osprey has reached its final position, they move to the seabed. In individual test phases, the 6 legs are each loaded with different weights. A specialist on the bridge monitors and controls the tests. This can take up to 10 hours. If necessary, he can also jerk the huge ship into place, because a firm footing is crucial. During the subsequent installation of the wind turbines, large shifts in weight occur when, for example, a tower is lifted from one side of the ship to the foundation. But first, the 6 legs now have to lift 26,000 tons out of the water and then withstand this weight securely. If the weather plays along, world records can be set.
The last trip we did, we installed 10 turbines in 10 days. That's okay.
So the guys standing by the legs, looking out for it.
The jack-up technology has been around for a while, but the Pacific Osprey's frequency of operation sets new standards. This is because the ship is raised and lowered every day. The legs are made of special steel to ensure that they can withstand wear and tear over a long period. This technology also requires completely new lubricants. A ship with myriad possibilities.
There was a storm in December where we saw waves up to 15 meters high. but we were up at 20 meters, so well above it. So if you have any tendency of seasickness, then it is a good vessel to be on, because we will never sail in bad weather. And if bad weather is coming, then we will just tack up.
Once the ship has reached its final height, the installation of the equipment begins. The wind turbines consist of several elements. Underwater, the foundation, the so-called monopile, is rammed up to 30 meters deep into the seabed. On top of this is the transition piece with a ladder for climbing the turbine and a small crane for lifting equipment. On top of the transition piece is the tower with the working elevator for technicians and service staff. The nacelle is mounted at a height of 88 meters. The 3 rotor blades are attached to its hub. Their total diameter is 120 meters. This gives the entire turbine an impressive height of 148 meters. Before starting each installation, the technicians have a team meeting to discuss the details of the respective installation. Because every foundation has its own special features, every tower is a little different. So every position requires a slightly different approach. The installation teams also take turns working around the clock. That's why the shift change usually takes place right in the middle of the installation process. It's for this reason that precise arrangements made among the teams are very important. First, the tower is erected. For this, the wind deflectors are now removed and the screws loosened. The crane of the Pacific Osprey plays a key role in the installation, and with it, the crane operator. 60 meters above the deck, he operates his huge Colossus, which can lift up to 500 tons. A 12-hour stretch in the pulpit, alone, always highly concentrated. No matter if it's the tower, the nacelle, or the rotor blades, a separate tool is used for each component to attach the individual parts to the crane hook. Before each installation, the corresponding tool is attached to the crane hook by the technicians. The 18-ton special device for the tower is called gripper. With its 4 oversized pincers, the tool grips the tower and holds it securely. There is no margin for error with dimensions like these.
The worst thing I could think of would be failure in the gripper and I lose the load. That's worst case scenario. That would be disaster. You would, what you call, shock load the crane then. You can't just lose 200 ton. It would whiplash the crane back. That's why you should never, you would never stand underneath a load.
The crane operator relies on the commands of the technicians at the bottom of the tower, and they maintain constant contact.
These guys are very good at what they do. They have 100% trust in Rennie there, and he's in the middle of the tower, in the middle of the grillage there, and he's watching it all round.
Stop there.
But I can very much only do what these guys tell me, you know.
Cable up slowly.
They're my eyes down there.
After the 136 bolts have been unscrewed, the huge tower is lifted out of its anchorage. Very carefully. It must not start swinging, otherwise it might damage superstructures or even other towers. With a calm but constant speed, the 66-meter-high tower floats over the North Sea to the transition piece. The lifting takes about 20 minutes. Slowly and precisely, 270 tons are lowered onto the transition piece. Inside, the technicians are already waiting for the tower to be fastened with the bolts. Millimeter work on the high seas. 12 hours alone in the cockpit. 28 uninterrupted days in a row, with total concentration. Time flies by.
A very quick day. You never find a day takes a long time. It's always hours just seem to disappear. Before you know it, your day is finished.
Once the tower is bolted down, the work inside begins. The technicians connect it to the power grid, put the elevator into operation, and switch on the dehumidification system. This prevents the technology in the tower from rusting quickly because of the salty sea air. While the technicians make the tower ready for operation and take the elevator to the top, things continue on board, and the crew preps for the next lifting. No one really cares that night has fallen again, but hunger makes itself known. Hard physical work in all weather conditions. That calls for decent food. The Pacific Osprey's galley is a modern industrial kitchen. Food must be available at all times. After all, everyone on board works around the clock. For the cook, this means that he always has to offer breakfast and dinner at the same time as the shift change, at 6 a.m. and 6 p.m. Because while the day shift is working, the night shift is sleeping. Michael Rattenburg is the master of the pots. Danish by birth, he also speaks German, English, and French. And that's how he cooks, because the ship's cook has to deal with different tastes on board.
The guys like different food. We're English, Dutch, Danish, German. So what do people like to eat? Spare ribs, for example. I cooked them today with a bunch of spices, and then I made my own barbecue sauce. Yes, that's what the Vikings like.
Of course, the menu has to be varied too. The meals are like little highlights in the daily routine.
We have a hot meal 4 times a day, and today, for example, we have 3 different dishes for lunch. For example, I have pasta with homemade pesto, then I have spare ribs, then I have an English dish, beef stew with puff pastry on top, and then we have Danish pork dumplings with rice, and then French fries with deep-fried parsley inside. That's the hot section. Then we have different kinds of salads at the buffet, also with ready-made salad like shrimp salad. And believe it or not, but the Northern Germans love it 24 hours a day.
The catering, and hence the kitchen, are of particular importance. The crew spends almost a month on the ship without interruption. Currently, the chef provides around 70 people with food around the clock. And in Michael's case, not just with food, but also with good humor.
Yeah, enjoy your meal, guys.
It's pork, minced pork with different kinds of spices, and a little bit of garlic and onions inside, in a mild curry sauce.
I should eat it with rice, probably.
You can eat it with everything. It's up to yourself. Cheers.
2 large groups on board. The ship's crew and the installation technicians always come together at meal times. Time to get to know each other. The English-Danish crew stays on board for 28 days and then has a month off. The technicians, on the other hand, work every 14 days according to German labor law. Over dinner, some questions can therefore be discussed and solved outside the official meetings. As soon as the tower is completely anchored in, the installation of the nacelle begins. Here too, a special lifting tool is first attached to the main crane. Inside, the power supply is switched over. Then, the crane begins to lift the nacelle. The nacelle weighs almost 200 tons. The men carefully turn it to face the correct direction using ropes. Again, exact agreements are necessary between the main crane operator and the operator of the lifting tool, which is attached to the crane hook. The enormous nacelle must now be safely maneuvered upwards past the other nacelles and between the ship's superstructures. The technicians are extremely focused, their gazes fixed on the floating colossus. At the top of the tower, at a height of 88 meters, the technicians are already waiting for the arrival of the nacelle. The nacelle already contains all the technical components needed for electricity production: gearbox, generator, and also the automatic control system. The latter always sets the rotor at the right angle towards the wind. 116 special bolts connect the nacelle to the tower. Each bolt is 22 centimeters long and 3 centimeters wide. At dizzying heights, the technicians now connect all the necessary aggregates to the tower. A red platform is attached to the nacelle. Later, here, service technicians can be roped down from the helicopter onto the wind turbine. Andre Henkensiefken is head of installation. During his lunch break, he shows us around the ship's interior.
Yeah, we have a beautiful view of our workplace, of the nacelles, of the rotor blades, but we're in the gym.
Although the technician's work is physically demanding, for many, that doesn't seem to be enough.
Here's the first common room, which is also used after work for playing billiards or chess with colleagues, or reading books. Now let's check out the cinema.
There are 2 state-of-the-art cinemas on board.
This is where the boys pass the time as we go from one site to the next.
Not quite the same as being on a cruise ship, but it has almost everything.
The leisure facilities also include a sauna. This is used in the late hours of the evening. Sadly, we don't have a swimming pool. We're on the 5th floor at the moment, where the night shift is. The day shift is on the 6th floor, so that there's no friction with banging doors.
Gone are the days of seafarers and technicians being tightly crammed in.
This is my kingdom. We don't have double cabins anymore, which is a huge advantage, of course, because you have your privacy after 12 hours of work. You can withdraw and relax, read a book or watch TV.
However, there is one thing not available this far out: a mobile network. The ship's Wi-Fi is what connects the ship to the outside world. On deck, technicians are getting ready to install the rotor blades. The men come from different countries. The common language is English, the atmosphere friendly. Many have known each other for a while, despite the offshore industry being relatively young. The most demanding task for the technicians begins with the lifting of the rotor blades. In their huge rack, the blades are now waiting to be assembled.
The blade weighs almost 19 metric tons, and we only have 15 to 20 centimeters of space at the top to lift the blade out on each side, and that requires accuracy and precision.
Besides the crane operator at the top of the tower, the lifting tool operator also has an important task. He's responsible for the fine control of the rotor blade.
Since we only have this much space, it can of course happen that you touch the other blade or some metal strut or something in the blade rack. Then you can easily damage part of the blade, which of course means immense costs to repair later.
Wind is the technician's greatest adversary. It determines the work rhythm and demands full attention.
We have a wind speed maximum of up to 12 meters per second where we're allowed to lift in, and you can feel it. Sometimes it works well at 12 meters if the wind comes from the right side. If it comes from the wrong side, you notice quite well that you're at the limit. The tower also moves accordingly. It swings slightly. The blade moves a bit and then works against each other, which makes it difficult for the boys to plug in the blade at the top.
The lifting tool operator controls the intricate movements of the rotor blades with the so-called tag lines. The operator of the main crane lifts the rotor blades upwards and towards the nacelle. Both have to coordinate closely.
You can be millimeters with this, especially for this type of work. When you come to be putting in blades and things like that, they need it very, very accurate.
Very slowly, the rotor blade approaches the contact point in the hub of the nacelle.
Okay, Jan, stop there, just right.
Here, 72 bolts have to be fitted exactly.
At the top is a long pin, at the bottom is a long pin. These are called guide pins, which have to go into two very specific holes so that the wing sits in the right position to produce enough electricity.
Modular work of a special kind.
A large set of Legos for big boys. Everything is a bit bigger, a bit heavier, but in the end, it's just Lego.
What sounds so simple, nevertheless, requires a highly competent and constantly focused team. Every mistake made during installation could cost hundreds of thousands of euros later on. So the technicians are always aware of their responsibility.
Many people have already come, stayed here for a few days and gone home. It was too high, too unsafe, not what people assume to be normal work in any case. Sometimes when you're standing here in the rain or snow, it's not much fun. But you know that the sun will come back and it will be warm again. Then it's back to being a dream job.
But erecting the wind turbines is only one, although important, part of a wind farm. Much is going on in the water surrounding it.
So in addition to the installation vessel where we are now, which is responsible for assembling the components, there's also a security ship for securing the construction site, a crew transfer ship for moving personnel and materials between the sites, a residential ship where the technicians are housed during the week, where they also push ahead with planning, and many other types of ships that are simply essential and responsible for the construction.
10 transport ships, so-called crew transfer vessels or CTVs, are constantly on the move in the 70 square kilometer construction field. They cruise between the wind turbines, the hotel ship, and the other larger ships in the construction field. Most of the time, the small and fast ships stay in the middle of the wind farm overnight and do not return to the mainland. The crews then spend the night on board their CTVs. The water taxis are special vessels, many with engines of more than 3,000 horsepower. They take the service teams to the turbines. During the construction of the wind farm, the technicians follow the installation vessel. They carry out further connection work on the turbines and prepare them for the final commissioning. The captains of the CTVs push their ships against the towers with all their might. This allows the technicians to climb over to the installation. In higher swells, this is not a safe job. The crews of the CTVs usually consist of 6 people. They spend day and night on their small ship for a whole month, working 12-hour shifts. Standard practice in the construction field.
The technicians are on 2-week rotations, which means they are really at sea for 2 weeks at a time. They're picked up from the hotel ship in the morning, dropped off at the site, and spend the entire day 12-hour shifts at the site. You have to be a special kind of person to enjoy that.
At the edge of the wind farm lies another larger ship, the Wind Ambition. The former ferry has been converted into a hotel ship. It houses people who also work on the wind farm, but are not directly involved in the construction of the wind turbines: planners, engineers, and the service technicians. At the end of the shift, the CTVs collect the team from the facilities and take them back to the hotel ship. Loaded with their gear, tools, and special equipment, the workers board the hotel ship and call it a day. In the hull of the former ferry, instead of cars, there are now rows of containers in which the equipment and material for the technicians is stowed. The engineers and planners work in specially equipped offices, monitoring the construction progress on site from here and taking care of the ongoing work. For some, this is a welcome change in working life.
Apart from my actual office in Hamburg, this is my second office here, where I spend a lot of time over the summer. I don't really mind it because it's just fascinating to be so close to everything that's going on. When you look out the window and you see the wind farm, it's completely different to looking at photos on your screen at home. It's a completely different impression and you're much closer to it.
Now, the engineers and logistics experts are still accommodated on the hotel ship. Later, they will live on a residential platform on the edge of the wind farm. By then, more than 100 people will live on the Wind Ambition. Most of them work on the wind turbines in the wind farm during the day. They come back at night and, of course, are looking for a change of pace and entertainment after a busy day.
We're now in the Buddha Lounge, the ship's central lounge. As you can see, there's not a lot going on during the day, but there are over 100 people living on the ship. And when you come by in the evening, you can see that people are using the football and poker tables, the table tennis, or the big TV in the back to pass the time.
As on the Pacific Osprey, catering also plays a big role here, just not around the clock.
Here we are in the restaurant. We have 3 hot meals a day with a choice of different menus. There's something for everyone. And you can serve yourself freely, almost like on a cruise ship. On special occasions, when the weather is good, there's also a barbecue on the roof terrace.
A lot of work on the wind farm is coordinated and controlled from the Wind Ambition. The spatial proximity has many advantages, like direct contact with the transformer station. The transformer station. It's something like the heart of Dantusk. It's the interface for transporting the electricity via the submarine cable to the mainland. The substation is 75 meters high, well protected against the rough weather of the North Sea. More than 100 kilometers of submarine cables run within the wind farm. They consist of a copper core that is 10 to 14 centimeters thick. Together with a fiber optic cable for data transport, they're protected by a steel wire sheath and a plastic layer. When laying the cables, a robot buries them 1.5 meters deep into the seabed. This is how the electricity will later reach the coast safely. When the installation work is finished, the dismantling of the Pacific Osprey begins. All brackets, fuses, and superstructures are tailor-made for Dantusk's construction. The huge rack for the rotor blades is dismantled, and everything that is welded in place is removed. After dismantling, the deck is free for the new superstructure of the next job. And maybe there will be men on board again who already know the ship. The men whose dream job is to build a wind farm. When it's completed, it will generate 1.4 billion kilowatt hours of electricity per year. Energy without CO2 pollution. Enough for 400,000 German households. One wind turbine per day. Thanks to the Pacific Osprey, the construction of wind farms is possible in record time. A second wind farm is already being built in the immediate vicinity, and the construction of another wind farm is planned a little further on. Perhaps a return to the largest installation vessel in the world.